Distinguished guests and participants, good morning to all. I'm Kok Seong, and with me is our Public Sector Enterprise Architect, Keith. We are both honored to be here this morning. Thank you for this opportunity for us to share with you our views about building the data platform for a data-driven city. As with all efforts to change or to transform, we should always begin with an end in mind. So in the next few slides, I would like to take us through 3 different data-driven solutions. I hope we can use these solutions to help us think about the challenges for the smart city of the future. Thereafter, Keith will take us through the mechanics of the data platform and how it can help drive smart city transformation that is data-driven. My first use case is Smart Dubai. This project is the result of a tight partnership between the City of Dubai, Du Telecom, and HPE. HPE was in charge of designing and implementing the smart city platform, comprising servers, storage, data protection, as well as partner solutions, all integrated with Dubai's citywide network. And the outcome is a data platform to provide citizens, businesses, and visitors with a seamless experience across different kinds of services in the city, making everything from finding parking to accessing healthcare easier, faster, and more satisfying. So, not surprisingly, the outcome was a 24% increase in happiness level in just 11 months, as well as significant government savings to the tune of $4.3 billion. So how did we do it? This diagram provides a simple presentation of the key transformation areas to achieve a smart Dubai. At the top are business initiatives. These are the innovations in the government business processes. And at the bottom is the IT modernization, done across the entire Dubai city infrastructure. And right in the middle, supporting and connecting the processes and IT transformations is the data platform. The data platform ingests big data from existing government systems, sensor data, and open data from the internet and other sources, including private enterprise and personal data. This platform enables virtually any government entity, private enterprise, or individuals to leverage the data and to create innovative applications and services that improves and enhances the way people live in the city. And we all know that in many cities today, more and more data are being generated every second. And a lot can be done if this massive amount of data can be harnessed to provide insights. Let me elaborate with the second use case. Most of you might have heard of the Autonomous Automobile Program. For this program, working with our partners, we created one of the world's largest global data platform. And they use it for autonomous vehicle development. Each car generates between 5 to 20 terabytes of data per day. And multiple OEM teams are actually using these streams of different data to train their AI models. And with more data, the models are getting better and better, speeding up the time to value for our customers. We are now at more than 235 petabytes of data, and we are continuing to ingest from more than 1,000 test vehicles every day. Our customers need to access the data from wherever they are and whenever they want. And we are managing that data security to support their access. If we compare this example to a smart city of the future, we can probably agree that the smart city will also need to deal with the challenge of continuous data creation, and for that at even greater scale. And the data platform needs the capability, the security, and the stability to deploy a huge range of data. Now let us go to the third use case, which is yet another different data platform design. This use case shows a distributed data platform solution, which we use for two of our oil and gas customers. The oil customer wants to increase the accuracy of maintenance, reduce mechanical outage, and downtime of their oil drilling operations. They need real-time data to be ingested at the edge, where the environment can be harsh and the network may not be available all the time. So sometimes they have to work on a disconnected mode. The second customer needs to reduce downtime for their refining operation. Again, working together, we deploy a distributed data platform to collect data from more than 200,000 sensors and refresh it every single second instead of the 30-second intervals that they used to have. So if we see at the bottom left corner, you can see a simplified multi-edge architecture where edge analytics are pushed to a global cluster and where AI can learn and pass on the improved model back to the different edge units. Similarly, smart cities will have to ingest massive amount of data at edge and yet be able to centralize their data and their learnings quickly and to speed up business processes and at shorter cycle times. So far, I've shared 3 different data-driven solutions with different data platform designs. And I hope these use cases can help us think about the data challenges for the design of smart cities in the future. So next, let me summarize with a simple diagram. The data platform right in the middle, connecting the business initiatives at the top and IT modernization at the bottom is most vital. So building the right data platform will help us achieve success in our efforts, whether it is for a smart city or for any other digital transformation projects. So while there are many data challenges when we design the data platform, I would like to suggest that we can start with these 4 key factors. First, access to data. Data access is always challenging because IT is often fragmented and there are many different data structures, inconsistent data format, and data silos created by many legacy systems. The second is on how to achieve trust in the data. Challenges are in data governance, data sharing, and the different data versions, and problems with data sprawls, data integrity, when they are collected or when they are transformed. And also we have to deal with data security issues. The third challenge is speed. So how fast can we add new data sources to test new AI models, to develop new applications? We don't want to waste time on day-to-day collection, cleaning, organizing, and management of data. And lastly, is cost. The exponential growth of data will make data management very costly if we can't optimize the structures. So how do we optimize the different data structures, data interface, and leverage the multiple data systems that we have? These are all questions that we have to consider in designing the data platform. With that quick summary, let's have Keith to take us through the data platform mechanics. And perhaps he will shed some light on the solutions. Keith, please.
Hey, thank you, Kok Seong. After hearing about the challenges of key transformational initiative, which is a reality in today's world, so today I'm here, I want to share with you some knowledge and insights on what we have learned. So what should we look out for in a next-gen platform? From the earlier use cases that Kok Seong has shared, there are various problems and challenges that was faced. And the conclusion is there is really a need to have one unified platform to manage all types of data and need to manage it at any speed from nearly any consumer source. And it has to have the freedom of the tools for all the users to work with that they can derive value from data. Must be able to build downstream operational applications to apply analytics and the artificial intelligence to the business in real time. So by having a uniform model, we'll be able to have control over IT. So control in security, in governance, in sharing, and also platform administration. So in short, we need to have an enterprise-grade data platform that has these qualities. And given all these complexities, from our experience, with the constant conversations that we have with our customers, our opinion is that customers' IT environments usually and may eventually evolve to become a service consumption model. And delivering it as a service will be the way going forward. So how do we go about doing it? And how can you go about doing it? We can go for a big bang or use case driven approach. And in these two approaches, the first one is the big bang approach. Organizations went for the big bang approach, built the platform, load the data, and then start to use it. So even if all the functionality was not needed on day one, and today we see a lot more people are going for the more and most cost-conscious use case-driven approach by identifying a specific use case and then building the platform with the components needed to address to it. So neither one is right or wrong. Both approaches works. And of course, there are advantages, disadvantages, and there are considerations that we will need to think about. In the Big Bang approach, there are a few strong advantages. You're able to implement a coherent architecture that was designed together from day one. So it will be one big project to stand up as a platform, as opposed to many smaller projects. Another plus point would be that it will be efficient if all the use cases can be identified upfront. However, such a large project also needs a larger upfront investment. And also there are risks of it not delivering value if the strategy and the directions are not clear from the start. And if we go for the use case driven, a plus point is that it could be more cost effective in that it delivers what is needed today. And subsequent use cases that will be lighter to implement as some of the components are already in place. So easier justification of investment can be achieved. And if these use cases has already driven the required value to investment, therefore the next use case that need to be run might be easier to secure in terms of investment. So, but however, use case driven requires a strong architectural vision to ensure that each of these use cases doesn't become a standalone silo. So each of these use cases will become a project in its own right that needs to be started, managed, and stopped, which could be less efficient from a project perspective as compared to one big entire project if you go for a big bang. So you have multiple smaller projects to manage. So which is a better approach? There is no right answer. It all depends on your business priorities, the fundings, and of course, the overall capabilities to run such a project. So let's unpack it. I want to bring you through a little bit under the hood to see why AI and big data are so different. So in this diagram, it shows the data flow through the data platform, from acquisition from diverse data sources to persisting, processing, and model creation. A key point is that the data does not only flow into the data platform, but it also back out to the edge and in many forms. When there are edge analytics going on, like the diagram over here, where the pointer is, there will be data inference results. There will be model movements. And when there is an increase in training at the edge, trainings of artificial intelligence and machine learning trainings, it means that more control over the process will be required. So different blocks for different cases form normal data lakes storage through the high bandwidth storage, and it feed the model training and simulations. And it result in multi-model data processing, where the data will go in round. And usually this data processing will be in batches, in stream, or in inference. So what's happening in the typical data pipeline workflow can be quite complex. Now, we have seen the complexity of data flow and what does it translate for you? This is an example of a data platform in a retail industry. The goal here is to develop a strategy that exposes all the data endpoints for both ingress and egress through a data services layer. This is a unique data model because it's unified. It also affords the possibility to leverage the same principles to acquire external data sources and then have them participate in the same ecosystem. As you can see here in this retail example, we have audit data, we have supply chain data, devices data, and therefore they can all participate in the same ecosystem, and all these data are taken into consideration. So what we are building now is a metadata-driven platform that unifies data from across the organization. It provides discoverability, data provenance, and governance. And by building a strategy in this way, it will allow the leverage of data in an iterative manner, meaning that the most impactful data can be focused on first, while leveraging data in existing sources without impacting the current application stack that is leveraging it. So we know that every data also has a life cycle, and each data source changes. The data does not have the same value when it is on its different life cycle journey. So therefore, a unified data platform that is able to work well within is very critical. And by having a good unified data platform model can be achieved by deploying a global data platform that will be made out of various components to form a data system ecosystem. And in such a complete structure, the business can continue to drive containerization to suit for different use cases and testing purposes to support the business. And also there will be a need to simplify end-to-end AI or machine learning workflow for collective business benefits. And this global data platform will be able to do so by using broad-based APIs that also creates a community innovation with a stack of softwares, various software vendors that it can work with. So lastly, cost control can also be achieved by using a consumption model, which will be achieved by delivery as a service. So now we have seen the use cases of using data platform. We have gone through a broad methodology, and we also went under the hood in details. And I've shared with you and hope that you understand why is it so complex. And also you can see the different dimensions required in managing it. So given all these challenges, how do we start looking at a unified data model? In HPE, we have the Esmero software portfolio. It includes key software components that can help you to achieve your digital transformation initiatives without the cost, the risk, and the time to move data and refactor non-cloud native applications to run in the public cloud. So this software portfolio is supported by HPE Pointnex services and may be offered as HPE GreenLake services, which is delivery as a service. It has been a pleasure today for us to be here. We hope that our sharing is able to provide some valuable knowledge for you. And for you to start thinking now, how do you want your next IT transformational initiative to be like? Is it going to have a unified data platform that will benefit your smart city of the future, benefit your people and the whole community? So think about that. And we will love to continue these conversations with you. Thank you for your time today.